All right, the question for today is from a horizontal distance of 8.5 kilometers, a pilot observes that the angle of depression of the top and base of the control tower are 30 degrees and 33 degrees respectively. Now calculate the shortest distance between the pilot and the base of the control tower. And then let's say calculate the height of the control tower. So we can say the pilot is somewhere here, and then the control tower we do not know yet, but let's assume that control tower should be downward here. Okay, so the height and base, the top and base. So this is the top, and this should be the base. So it's 8.5 kilometers apart because say the horizontal distance a pilot observes, yeah, the angle of depression. So he was at like 8.5 kilometers away before when he observed the top and bottom of the tower. All right, so this is the tower, right, and this is where the pilot is. So just take note of that. All right, so now what he observes is the top and bottom in terms of angle of depression. So he first observed 30 degrees um, for the top. So you know that if this is the frame of reference, 30 degrees from here will be like something around this point. So you'll be able to draw it to the top, right? Then 33 degrees from that same point could be a little bit after that. So from that same point there, you can draw down to the bottom. Okay. So with this now, you can get um, the diagram for the pilot and the tower. So you see it forms a very strange diagram here. So if you want to redraw this, you can have the pilot here, and then um, the base and top. Let me do this way. The base, okay, the base and top of the tower will be something like this. Okay, so this is the pilot here. This is the tower here. Okay, and put it something like this. So this is going to be uh, 30 degrees, and this is going to be 33 degrees. And the same way, if you have it like this, this will be 30 degrees, and this other one here will be 33 degrees. All right, so you understand this part alternate to this part, and this part here is alternate to this part here. So this is the diagram, and this is the original, just for you to understand the pictorial illustration. But what they want us to do is to calculate the shortest distance. Basically, you already know that the distance between the pilot and the tower is 8.5 kilometers. Okay, you already know that. But they want us to find the shortest distance, not from the pilot and the tower, but the from the shortest distance between the pilot and the base of the control tower. So this is the pilot here, and this is the base of the control tower. So they want us to find this distance here. All right. So how would you do that? All right, let's think about it. You know that this is 90, this is 90. You already have an adjacent here, okay? But you're looking for this one here, which is obviously the hypotenuse. And if you separate these two diagrams, you see it forms diagram something like this, and another shorter diagram like this, where you have this one to be 33 and this one to be 30. You know, based on top and bottom. So this should be the diagram for the base, and this should be a diagram for the top. So you know you have something like this. So with this now, you have 8.5 kilometers here, which is the same thing here though, since they share the same base. You know, this is the same length with this, the same distance. Okay. So with this now, you'll be able to see how you can find the distance between the pilot and the base because this is the base. So using SOHCAHTOA also, we have adjacent, we have hypotenuse here. So adjacent over hypotenuse is cos. So that will help you understand what to do. You have using cos, you'll be able to find the shortest distance. So cos 33 degrees is equal to adjacent, which is 8.5 over hypotenuse, which is h. We do not know that. That's what we're looking for. So that means h is going to be 8.5 over cos 33 degrees. And that will give you what? That should give you 10.14 kilometers. Yeah. So that is it. So we found the what do you call it? Shortest distance between the pilot and the base of the tower. So that means here, this part here is going to be 30. We'll just put this part here is going to be 10.14 kilometers, right? So we've gotten the first part of the question, but now they said in the second part, calculate the height of the tower, the control tower. Now, how would you do that? Maths can really be funny because like they've already given you informations, but how would you really find the height of the tower itself? They didn't even ask the height of the um, what do you call it, the pilot and the ground, because this would have been easier to find. Um, but now you have to find the control tower. The control tower is like kind of like away from the diagram. So what you need to do is you need to understand that the height of the control tower corresponds to this point here. So this is the top of the control tower. Let's call it K. This is the bottom. Let's call it um, L. So it corresponds. If you trace it down, it corresponds to this other side here, K and L. They're the same distance, the same height. So basically, if we are able to find the total height here, if we're able to find the total height here, and then we find the height here, when we will now subtract this height from this point to this point, and then we'll be able to get KL. That's it. So how would we do that now? First things first, let's find the bigger height from the pilot to the ground, and let's see what we can do with that. So to find that, we need to know, we already know, we can use some SOHCAHTOA also. Using this smaller diagram that I have here, you can have opposites, let's call it big H, over adjacent, which is 8.5. So we can use tan. We can use tan. So we can use tan 33 degrees equal to opposite, which is big H, over adjacent 8.5. That means we have H equal to tan, 8.5 times 8.5 times tan 33 degrees. And that will give you what? That should give you 5.520 kilometers. 5.520 kilometers. Alright, so that's the first one. But now we need to know this other height here, this point here. Let's call it J. So JK, we need to know JK. So how would we know JK? Remember that we separated the diagram so that we have the one for the top here. So this is J and K.